In this video, let us continue to solve more problems based on complex numbers. Alright, here we've got the question. It says, find the real values of x and y if 3x minus y plus 2iy equals minus 5y plus 5 plus x times I. So this is based on equality of real numbers. If you recall from one of the previous videos, if we have two real numbers, say for example, z1 equals a1 plus ib1 and z2 equals a2 plus ib2. z1 and z2 are said to be equal if a1 is equal to a2 and ib1 is equal to ib2. So in this case, all we have to do is just equate the real parts and equate the imaginary parts. That's all we have to do. So taking the real parts, we have 3x minus 7 equals minus 5y. And taking the imaginary parts, we have 2y equals 5 plus x. Of course, we are not supposed to take the I part of it to solve it. So in this case, you just leave the I and take 2y. You don't have to really worry about anything because it's just one single term. In this case, the I is already factored out. So now what happens is we've got two equations. So just group them in the right way. So say for example, make it 3x plus 5y equals 7. Push 5y to the left hand side and push 7 to the right hand side. Negative 7 to the right hand side becomes positive 7. And then we have x minus 2y equals minus 5. You just have to push 2y to the side of the x and push 5 to the opposite side, and this is what you get. So now we need to use the simultaneous equation to solve these two equations. So say let's start off eliminating x. So the coefficient of x here is 1. So multiply 1 on the other equation and multiply 3 here. I'm not going too deep into these because we've already done all the simultaneous equation stuff. So 1 times 7 is 7. 1 times 5y is 5y. 1 times 3x is 3x. So 3 times minus 5 is minus 15. 3 times minus 2y is minus 6y. 3 times x is 3x. So changing the sign, subtract it. You have 3x getting cancelled. Change the sign, you have 11y, and change the sign, you have 22. So therefore, you have y equals 22 divided by 11, which is equal to 2. So we found the value of y. So now to find the value of x, all that we have to do is just substitute the value of y in one of these equations. I'll choose this one. So we have 2 times 2 equals 5 plus x. So we have, I'll continue here. So we have 4 equals 5 plus x, right? Or x equals 5 goes to the left hand side. So it becomes minus 5 plus 4, which is minus 1. So x equals minus 1. So therefore, the real values of x and y, if the equations are so and so, we have y equal to 2 and x equal to negative 1. So this is what we have to do. Let me repeat before I conclude this problem. To find the values of x and y when you have two complex numbers being equated against each other, all that you have to do is equate the real values. That is, the one which doesn't have the I is called as the real part of the complex number, and one which has the I is called the imaginary part. So just equate the real parts of the imaginary parts and make an equation and solve the equations and find the values. That's all you have to do. It's not really complicated at all. The only concept to remember here is equating the real parts and the imaginary parts. Once you do that, it's all elementary mathematics, nothing else. So that ends this problem. Let's quickly solve another problem before we end this video. Alright, here we've got another problem. So find the real values of x and y if x plus iy times 2 minus 3i equals 4 plus i. Before we do anything, we need to multiply these two things. So I hope you remember the multiplication rules of complex numbers. If there are two complex numbers, a1 plus ib1 and a2 plus ib2, if these two have to be multiplied, you have a1 a2 minus b1 b2 plus I times a1 b2 plus a2 b1. So this is the formula that you have to follow for multiplication of complex numbers. So here we have a1 a2. So a1 a2 is going to be 2x minus b1 b2. So b1 b2 is y and negative 3. So it's going to be minus 3y. There's already a negative sign here. So it's going to be plus 3y. Alright. Plus I times a1 b2. a1 b2 is minus 3x and a2b1 is 2y, so plus 2y equals 4 plus I. So now this is of the form a plus ib. So we can stop at this and now start to equate the real parts and the imaginary parts. The real parts are 2x plus 3y equals 4, and the imaginary part is 2y minus 3x equals 1, because I is multiplied with 1. It's just 1 I, so it's just 1 there. So now solve this. You have 2x plus 3y equals 4 and minus 3x plus 2y equals 1. So cross multiplying 2 and 3 of y. So 2 times 4 is 8, 2 times 3y is 6y, 2 times 2x is 4x, 3 times 1 is 3, 3 times 2y is 6y, and 3 times minus 3x is minus 9x. So now changing the signs, we have 6y and 6y getting cancelled, 4x plus 9x is 13x, 8 minus 3 is 5. So therefore, we have x equal to 5 by 13. Now that we found the value of x, we need to find the value of y by substituting the value of x in any one of these equations. So let me choose this one here. So we have 2y minus 3x equals 1. So 2y minus 3 times 5 by 13 equals 1. So 2y minus 15 by 13 equals 1. So 2y equals 1 plus 15 by 13. 1 plus 15 by 13 is solving it. You have 13 plus 15, which is 28. 28 by 13. Or y equals 2 goes 14 times in 28. So y is 14 by 13. So now finally we found the values of x and y. X is equal to 5 by 13 and y equals 14 by 13. Alright, so that ends this problem. It was not very different from this except for the fact that you had to multiply it before, before equating the real and the imaginary parts. That's the only difference between these two problems. If you notice carefully, here it's already in the form of a. This whole thing is a plus I, whatever is the rest is b. So a plus ib, a plus ib. But here it wasn't like that. It was like different. So you need to multiply it and get it to the form of a plus ib equal to a plus ib, and then you can equate the real parts and the imaginary parts. Alright, so that's what is the major difference between these two problems. Otherwise, both the problems have been pretty elementary after equating the real and the imaginary parts. It's just simultaneous equation and finding x and y. Nothing, very complicated. So that ends these problems as well as this video. I'll see you in the forthcoming videos with more problems based on complex numbers.